Hello everyone, we have a system of linear equations involving three unknown variables. Before we start, which method do you think is the best? For me, I'm going to try Cramer's rule. Alright, according to Cramer's rule, I'm going to take it step by step. First of all, we are going to find the determinant of the constant coefficients of our variables. So the coefficient of x, you can see them 2, 5, and 7, 2, 5, and 7. For that of y, we have 1, negative 3, and 1, 1, negative 3, and 1. For z, we have 1, 2, 3. Let's find the determinant. This is a 3 by 3 matrix, right? But before you start, assign sign, plus, minus, and plus. Take the first number here, which is plus 2. Open a bracket. You close these elements, you close these, we still have 4 other elements. And how can we find the determinant of these 4 elements? You cross like this, negative 3 times 3, which is going to give us 9, negative 9, you write here. The minus, this minus is always constant. You multiply these other diagonals, 1 times 2 is 2. You are done with the first entry. Then you move to the second one, which is what? Minus 1. Minus 1, open your bracket, you close this, you close this. We still have these 4 elements. The determinant will be 5 times 3, which is 15, minus 7 times 2, which is what? 14. They will move to the last entry here, which is plus 1. You open a bracket, you close this, you close that. We have 5 times 1, which is 5, minus 7 times negative 3 is negative 21, but already we have a negative here, so this becomes positive 21. So now let us evaluate this. Minus 9 minus 2 is minus 11 times 2 is minus 22. 15 minus 14 is 1 times negative 1 is still negative 1. This plus this is 26 times 1 is still 26. This is equal to positive 3. And hence the determinant of the constant coefficient is equal to 3. Next, we would like to find the determinant with respect to x. The determinant with respect to x will be equal to what? We are going to form a matrix of constant coefficients, but we are going to replace the x-axis with the constant terms. What are the constants? We have 8, 3, and 20. So we write 8, 3, and 20, but the rest will be the same. We have 1, negative 3, and 1 for y, 1, negative 3, and 1. And for z, we have 1, 2, 3. 1, 2, 3. The same strategy, we have plus, minus, plus. The first one is what? Positive 8, open a bracket. If you close this, you close that, you have negative 3 times 3, which is negative 9. Minus 1 times 2 is 2. Then minus 1. Close this, close that, you have 3 times 3, which is 9, minus 20 times 2, which is 40. Then lastly, we have plus 1, open a bracket, close this, close that, we have 3 times 1, which is 3, minus 20 times negative 3 is what? Negative 60. But we have a negative here, so this becomes positive 60. So let's evaluate this. Negative 9, negative 2 is negative 11 times 8 is negative 88. Move to the second one. 9 minus 40, negative 31, right? Times negative 1, that will give us positive 31. Then in the other bracket, we have 3 plus 60, which is what? 63. Times 1 is still 63. We have negative 8, 8 plus 31, which is negative 57. Then we add to 63. That will give us 6 exactly. Therefore, the determinant with respect to x is equal to 6. Then we need to find the determinant with respect to y. We're going to form a matrix of constant coefficients. All other coefficients will remain the same except that of y, which is going to be replaced with constants. So we have 257 for x, 257 for x, but for y, we are going to replace them with the constants, 8, 3, and 20. 8, 3, and 20. Then for z, it remained the same, 1, 2, 3. Don't forget the sign, plus, minus, plus. We have plus 2 multiplied by, if you close this, you close that, you still have 3 times 3, which is 9, minus 20 times 2, which is 40. Then the second entry is what? Minus 8. Open a bracket, close this, close that. You have 5 times 3, which is 15, minus 7 times 2, which is 14. Then lastly, we have plus 1. You close these, you close these. We have 5 times 20, which is 100, minus 7 times 3, which is 21. 9 minus 40 is negative 31, times 2 is negative 62. This minus this is 1 times negative 8 is negative 8. This minus this is 79, times 1 is still 79. Let's simplify this. We have negative 62 minus 8, which is negative 70, plus 79, that will give us 9. Therefore, the determinant with respect to y is equal to 9. Then lastly, we need to find the determinant with respect to z. The determinant with respect to z will be the matrix of the constant coefficients. We have for x what? 257. 257. For y, we have 1, negative 3, and 1. 1, negative 3, and 1. Then for z, we are going to replace them with the constants, which are 8, 3, and 20. 8, 3, and 20. Let's find the determinant. Don't forget plus, minus, and plus. All right, we have plus 2 multiplied by, you close this, you close that. We have negative 3 times 20, which is negative 60, minus 1 times 3 is 3. Then you move on to the negative 1. You close this, you close this. You have 5 times 20, which is 100. Then minus 7 times 3 is 21. Then lastly, we have plus 8. You close this, you close that. You have 5 times 1, which is 5. Minus 7 times negative 3 is negative 21. We still have negative, so it becomes positive 21. Negative 60, negative 3 is negative 63, times 2 is negative 126, right? Negative 126. This minus this is 79, times negative 1 is negative 79. This plus this is 26, right? Multiplied by 8, that is 208. So let's add up. We have negative 126 minus 79 plus 208. That will give us 3 exactly. So this is the determinant with respect to z. Therefore, to find the value of x, you take the determinant with respect to x, you divide by the main determinant. And the determinant with respect to x is equal to 6. The main determinant, you can see it is 3. So we have 6 divided by 3, which is equal to 2, right? Value of y will be equal to the determinant with respect to y divided by the main determinant. The determinant with respect to y is 9. So we have 9 divided by the main determinant 3, and this is equal to 3. Then the last one, which is z, is equal to determinant with respect to z, divide by the main determinant. This is equal to, you can see that this is 3, right? Divide by the main determinant, which is 3 also. This is equal to 1. And hence, the values of x, y, and z equal to what? 2, 3, 1. Yay! This is the solution to this problem using Cramer's rule. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.